Hi, welcome to Connect. It appears when I'm one of the first up after Lee's keynote. With the new format for this Connect, we don't even have Joe's witty facts or Dave's always fun challenge. Anyway, I'm Peter Robinson. I'm sure a few of you know who I am, but here's a quick intro. I work for Red Hat. I'm the principal architect for device edge and IoT for the OS layer. Basically, it's my team's job to make the device boot and be able to run apps so that everyone else can do the cool things. So today I'm going to discuss why standards are important for the edge. As part of my role, I work on standardization efforts, as well as engaging and working with internal teams at Red Hat, open source communities, and with customers and partners to work out what the problems we need to solve are. And there are many. But also to solve for Red Hat, but also for the wider Linux ecosystem, so that customers have choice when running their IoT platforms. If you look at the enterprise data center, there's a lot of commercial off-the-shelf systems that boot and generally work in the same way. But customers are able to run a vast array of general or proprietary software to execute vastly different workloads in a similar method. Speaking with customers, they expect the same on the edge, but a lot of their experiences to date haven't met with the expectations. So I'm going to cover some of the ways edge is different from the data center, but why standards are still just as important, even in this diverse environment. So what is edge? Edge is many things, and different things, from the home to the enterprise to telco, and even multiple of those things to the same industry. A bit like cloud, the edge means many things to many people. It has many advantages. These include things like reduced latency and bandwidth requirements, increased resilience, and even things like data sovereignty, for where countries can require data to be in particular locations. In some circumstances, it provides increased security and reduces cost, but it also has its challenges. You'll notice some things like security and cost appear on both sides of the list, but also things like environmental challenges, scale, and other factors in as well. I once had a customer say to me, "We deal with everything with some of our sites, including pirates." As I alluded to in the last slide, there's also a number of various definitions of edge and various tiers. Everything from telco and provider edge. These can include things like 5G and 5G vRAN, CDNs, and a number of other services that telcos and service providers provide. Enterprise edge, like retail and branch offices, as well as factories and warehouses, are another section of edge. But then there's also device edge, and this area is just massive. It covers many different facets and types of equipment, from small battery-powered sensors through to systems almost as powerful as those in the data center. These can be everywhere, from a washing machine in the home, cameras in the street, to cars and wristwatches. Different people and different customers define edge differently, and the definition of edge is always quite a fun topic to discuss with people. Anyway, so why do open standards matter on the edge? I feel open standards are important. The PC became the instant success it was, not because of any one particular feature, but because it could be readily cloned, and all these clones could run the same software, even if the hardware was different. It meant they were widely available and relatively cheap to acquire. But also things like the internet became a success due to open standards like TCP/IP and HTTP. Who remembers networking protocols like IPX, SPX, NetBIOS, or DECnet? They've all been replaced by TCP/IP. And even some of the early internet protocols have been readily replaced by HTTP. Who remembers Gopher? Being open protocols allowed everyone to implement them and for different systems to interoperate. Even old mainframe systems that have been constantly upgraded from the 1960s that used to run serial and various other protocols are now connected via IP to do basically the same thing they were probably doing 20, 30 years ago, even if the hardware underneath has changed. Open standards provide low barriers to entry. So open implementations in software to consume, but they also protect companies' investments. They prevent lock-in. Remember, lock-in is a two-way street. While it means customers can leave you and go elsewhere, it also means that your platform could be the reason the customer is leaving. It also means your platform could be the reason customers are leaving the others. It allows competition and it allows companies to move and adjust as various things change. Some companies may not be around in a few years' time, and so the ability for them to be able to move software or hardware to different platforms is very, very useful. I won't spend a long time on this slide, as I'm sure everyone has seen it. And if you haven't, go and check out XKCD standards slide. It summarizes the need for open standards quite well. I mean, just look at the amount of wireless standards there are. So, you know, while we're talking about hardware and hardware standards and various other things, there's also other standards that are useful on the edge. Enterprise standards, things like, companies are used to things like Linux distributions just working. And so standard enterprise distributions like RHEL and Ubuntu, as well as other community ones like Fedora, CentOS, and Debian, being able to run on any platform without changing and having custom kernels and various other bits and pieces are important. Companies, whether they're telco or enterprise, don't want different OSs and different procedures for each different device they need to support. On the edge, there could be thousands of different devices, from large servers, high-end machines doing artificial intelligence and inference, to small gateways. And they don't want every single different device to have a different operating system and a different software stack. They want to be able to choose a single software operating system and operations stack that allow them to run on whatever hardware they want and whatever hardware is best for the job. If they've got tens of millions of devices or even only thousands of devices out there, there may be 3 or 4 different requirements for devices, and having different software stacks for each of those makes it hard. Because so, and having a single software stack and a single standard for booting and securing enables more secure systems, knowledge reuse by data center admins, and them to choose the right hardware for the job rather than being stuck with single hardware because of the software stack they chose. They basically want their edge software to look and work like the data center software. So their developers can deploy the same things the same way, and their operation teams and sysadmins can share the same knowledge. This sort of rolls into security as well. Devices on the edge are often running workloads similar to the data center. They contain critical information such as VPN, proprietary software, and algorithms, but rather than just the physical security of the software, rather than the physical security of the data center with 4 walls and access control systems and authorized audited people, they're strapped to light poles, pipelines, pumps, often in the middle of nowhere. A customer once said to me we don't even bother putting up fences around most of our equipment because it's so isolated that someone could just drive through the fence or climb over it. And even if we had cameras there, they would be away and gone with all the pieces before we even manage to respond in the central location. So they just don't even bother. It's an extra cost they don't need. So to secure devices at the edge, we need higher levels of security and lockdown to provide security as close to the physical data center as possible. Things like TPMs for critical recovery of non-critical information, the Trusted Computing Group standards with the Linux IMA for measurement and attestation, UEFI Secure Boot to verify that the operating or the software stack hasn't been changed between reboots, and also emerging hardware technology like security enclaves with software such as those technologies being worked on in the Confidential Computing Consortium will also help here. And also standards like Parsec from the ARM, also standards like Parsec to make it easier for developers to secure critical information and data across different devices that may have different hardware. That way, they don't need to care about whether they're speaking to a TPM or a PKCS11 interface or some other hardware technology. They can basically just use the same API and be guaranteed that the information is stored securely. That also brings me to provisioning and onboarding standards. There's a number of ways to implement devices, implement OS and deploy devices from bare metal. How do you get a remote device up and running without specialist people? How do you make these devices work without rolling a truck? Or if one fails, get it up and running as quick as possible? How does a company ship a device directly from the manufacturer to any site they like and have an on-site employee, such as an oil worker or a retail assistant, get it up and running without the needs of IT specialists? And how do they do that for thousands or tens of thousands of devices, for any device from any manufacturer in any region? If an IT team is centralized in the US and they need to deploy a device to Australia or to Singapore or the Middle East, do they want to be flying out specialist engineers, or do they just want to log a ticket with a supplier and have that supplier ship the device from the nearest location so it can get there as quick as possible? So things like secure device onboarding that came out of Intel and is now an ARM and Intel collaboration, I feel are critically important to some of the standards for Edge. Being able to securely onboard these devices using people in the field is the only way we're going to scale and secure devices in a way that Edge needs. And similarly, as we go up from hardware into the software layer, application standards are useful, and containers are where it's going in the data center and are completely hot for development process at the moment. OCI containers continue the vendor agnostic standards further up the stack. You can easily deploy the same application in the data center as on the edge using the same methods. Each application is independent of the underlying operating system and every other application running on the system. They can each have their own choice of libraries. They can be updated independently, controlled separately, and isolated from one to the other, so that if one of the applications get compromised, it doesn't necessarily mean all the applications are compromised or the underlying OS is compromised. And it can be dealt with in a single way. Also, having DevOps processes and CI pipelines assists in deployment and standardization in this method. Thank you. I'll be around on Slack for any other conversation. And there's also a bunch of other talks later on in Linaro Connect around some of these things, including a Parsec one later on today. Thank you.